Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. I am Dr. Qaisar, professor in the Department of Civil Engineering and also Dean of the Faculty of Civil Agriculture and Mining Engineering. I will teach you this course, Reinforced Concrete Design 1. As the course name suggests that this course is about the reinforced concrete, and it is an initial beginner level course, an introductory course. There are two more courses on this subject. One is Reinforced Concrete Design 2, which is start in the 7th semester, and then there is an Advanced Reinforced Concrete Design, which is start in the master courses to structural engineering students. The OBE course content of this semester, spring 2021, you can go through this yourself. They are self-explanatory, but briefly I will tell you about the course. That this course is a design course, and we will be designing several components of the reinforced concrete frame structures like beams. I hope you know what a beam is. We'll be designing beams which are horizontal members in a reinforced concrete frame structure, and vertical members, columns. We'll also be designing columns, and the two-dimensional members such as slabs will also be discussed in this lecture. Side by side, we will be discussing the relevant codes which will be used throughout this course. The most famous code which is used in reinforced concrete design is ACI. ACI stands for American Concrete Institute, as you will see in today's lecture in quite detail what are the different types of codes and what ACI stands for and why we will be using ACI code in our course. Then since this is a design course, so after you study this course and also other courses, as I said earlier, Reinforced Concrete Design 2 in Masters in Advanced Reinforced Concrete Design. Some of you may like to join the Master in Structural Engineering course. So there they will be able to also study that advanced level course. And once a student is well equipped with the content and the concept of these courses, we will be able to design high-rise buildings, low-rise buildings, even bridges, dams. Because throughout this course, the basic concept of reinforced concrete design will be discussed. And after you study these basic concepts, not only buildings, but other structures, civil engineering structures, can also be designed using the basic concept of this course. So this is a very useful course, it's a productive course, and this is an applied course. You would have studied courses like mechanics of material, strength of material, structure analysis courses, and wherein you would have thought several times in your mind that why these courses are being taught to you. Because they are pure theoretical courses, mechanics of material, structure analysis, strength of material. So sometimes the students get bored in the courses, and this is a very common question that arises in their mind, that why these courses are being taught to civil engineering students and how we are going to benefit from their courses and where these courses will be used. So it is the course and it is the subject reinforced concrete design where you will be using all those courses which you have learned in your previous semesters. So this is a very practical course because you will see beams, columns, and slabs, reinforcement in them. And I myself is involved in the high-rise building designs, in the bridges designs, and we have designed several high-rise buildings recently in Peshawar and Islamabad. Our most recent projects on the University Road are Diamond Mall, high-rise building, around 18-story, reinforced concrete frame structure with 4 basements, 40 feet down the ground. and then ground plus 12 stories, so it is around 13 plus 4 is 17-story structure, which is on the University Road. You can see 4 floors of the structure. 4 floors of this structure are now visible from the road. And then there is another high-rise building again on the University Road. It is near the Board Bazaar. It is when you go to the Board Bazaar, it is on the left side near the UPS. And this is a big structure. This is a big structure, again 17 to 18 stories. And if you want to see some of the reinforced concrete frame structures during construction, you can visit these sites because these have been designed by me and in our office at DQA. We have been working on several other structures in Peshawar and Islamabad and in the surroundings, where we are designing reinforced concrete frame structures, also brick masonry structures. We are also working on the rehabilitation and retrofitting of the structures and the structural health assessment and rapid visual cleaning of the structures. So this course is very relevant course to the civil engineers, where you can apply your knowledge which we have learned in the previous courses in this course. So you should pay attention to the basics of these courses because this is a beginner level course. So most of the time we will be talking about the concepts involved in this course, the mechanics of material associated with our design, not all mechanics of material. And since the name tells us that the course will be about reinforced concrete, you know that concrete is very good in compression. You must have studied a course in concrete, wherein you would have studied several properties of concrete, like concrete is good in compression but weak in tension, and so on. And you would have also studied what are the constituents of concrete, like cement, sand, and aggregates. Water is added to make a paste from cement, and then this paste will glue or will bind together the sand and aggregates and will form a hard material on hardening called as concrete. It will become a stone-like material. So this stone-like material, which is called as concrete, and the primary constituents of this material are cement, sand, and coarse aggregate plus water, is very good in compression, but it is very weak in tension. So wherever this concrete is subjected to tensile stresses, like a beam, simply supported beam, when subjected to transverse loading like uniformly distributed load, you would have several times drawn shear force and bending moment diagram for a simply supported beam when it is subjected to uniformly distributed load. And you would have seen that when a beam bends due to uniformly distributed load or a point load, I am talking about the simply supported beam, then tensile stresses will be produced in the lower fibers of the beam, and compressive stress will be produced in the upper fibers of the beam. So the upper fibers will resist the compressive stresses because concrete is good in compression, but the lower fibers of this beam will not be able to resist the tensile stresses, and the beam, if it is made of pure concrete, will break very early. And for this purpose, the lower part of the beam will be reinforced. This reinforcement is usually provided in the form of reinforcing steel bars. You must have seen steel bars in the market and elsewhere in some construction place. These are bars very readily available in market from in different diameters of the bar. There are 2 grades of the bars, grade 40 and 60. So these bars are very readily available. We in our design course will be calculating the quantity of these bars to be placed inside the beam. And once these bars are placed inside the beam along the direction of the stresses, then the concrete beam will act now like a composite structure, the upper portion of the reinforced. Now this beam will be this concrete will be called as reinforced concrete, and the beam will be called to have been constructed from reinforced concrete. So upper part of the beam basically consists of concrete, and the lower part of the beam will contain the reinforcing bars. No doubt concrete is also there, but then concrete is properly bonded to steel bars in the lower side of the beam. And when the concrete beam is subjected now to flexure stresses or bending stresses, the upper part will be pushed and compressed So the concrete is good in compression, nothing will happen to the upper part. And the lower part of the beam will be stretched. And this stretching will cause tensile stresses. And as I said earlier, concrete alone is not good in resisting the tensile stresses, but since there is steel, there are steel bars now being placed inside concrete. So these steel bars will basically resist the tensile stresses, and it will increase the load carrying capacity of the beam. So in this way, in this course, basically we will be calculating the amount of steel which will be placed inside the beams or columns or other members of the reinforced concrete frame structure, reinforced concrete frame structures. So this calculation of the amount of steel is called as design. And also, along with the calculation of amount of steel reinforcement, we will also be calculating the size of the section required to resist those stresses. So basically, in design, we will be determining two things. One is the size, the appropriate size of the member, be it a beam or be it a column or slab. So design is basically the calculation or determination of size, number one, and number two, the amount of reinforcement in a reinforced concrete structural member. So the two things you should remember: size of the member and amount of reinforcement that will be needed to be calculated in a design problem. These two things will be. And you should also remember that before designing, you would need to exactly know the magnitude of the stresses which need to be resisted by steel. So this will be done using the shear force and bending moment diagrams. You would have done several times you would have run the shear force and bending moment diagrams in your structural analysis courses. And as I said earlier, you would have thought at that time that why are we drawing these shear force and bending moment diagrams? What is the use of this? So you will be using actually in this course these shear force and bending moment diagrams. Once the bending moment diagram is drawn, you know that bending moment diagram. When bending moment diagram is drawn, at every point along the length of the beam, you know exactly what is the value of the bending moment. So we'll be designing our beam against that bending moment, and so you exactly know what the magnitude of the bending moment is, because if you do not know the magnitude of the bending moment, which is causing the tensile stresses, for example, in a simply supported beam on the lower part of the beam, then we will not be able to calculate the amount of reinforcement. Okay, so this is just a briefing about this course, so that you know what we will be studying in the next lectures. And also, in this particular lecture, we'll be concentrating on the basic concepts, the properties of the material, and also the codes which are to be used in this course. At the moment, on this slide, there is the OBE course content 2021. I suggest that you go through this yourself because it is self-explanatory. You will be able to see the topics and how these topics address the OBE outcome-based education, different learning outcomes. So you can see this later yourself. On the next slide, we have a grading policy, which is in line with the university policy of grading. The midterm has a weightage of 20%, final term 60%, and class participation is 20%. This slight variation in these weightages are possible if there are if the examination is online. So you know that in online examination there was slight change in these weightages, so you will be informed well in time about these changes. The assignments and quizzes and complex engineering problems, CEP, and the weightages are also given for these three activities. The schedule of assignments and quizzes has already been uploaded in our classroom, so you can also download this and you can go through this yourself. Because we will not be announcing every time the assignment and quizzes. They are already given, and you should come prepared for the quizzes, and also you should submit your assignments well in time, so that there is no issue of delay in the submission of assignments. Okay, the availability of the lectures. All these lectures which will be taught to you in this course are already available on my personal website. which is www.drqaisarali.com. You can visit the website and you can find several useful material along with the lectures on reinforced concrete design 1. However, if there is any change, because every time when we teach this course, every time we update the lecture. So after, if the lecture is updated, you will be informed, and the updated lecture will be uploaded on the website soon after the lecture ends. Now, coming to today's topic, it is Introduction to Reinforced Concrete Design, because the course will be introduced today. Something general about the course: why are we studying this course and the properties of concrete and steel? As I said earlier, because if you do not know what the properties of concrete and steel are, you will not be able to realize the importance of this course, and the next lectures will be totally about the adjustment in the concrete. Because this, as I said earlier, the design is to calculate, to determine the size of the member and to calculate the amount of steel. So unless you know the properties of these two materials, which will be used side by side in every member, you will not be able to properly understand how a design will finally end. So, and then the codes in the ACI code, there are codes, different codes which we will be using in this course. These codes are important because in the design problem, as you will see in the next lecture, if I give you a design problem to your class, and if you are 40 students, every student will come up with his different answer, and all the answer might be correct, because in the design problem there is no unique solution. Because when we say that we will be determining size of the member and amount of reinforcement, so size of the member is not a unique size. There will be a range of size, let's say from one to another end. So within that there will be many sizes which will be out of which all will be correct, and maybe some of them will be very optimized sizes and will be very convenient and economical, but we cannot say that another size is not suitable, because it will, as you will see in this design problems, that it will depend on many things. It will depend on many things, and sometimes it is quite possible that every designer come up with a different solution. So in order to make a uniformity in the design, and in order to fix some minimum criteria, for the design, so that life safety is ensured. Because you see that all these structures which you will be designing will be occupied by people, and life is very precious, it is priceless. So life safety is the first and the prime objective of a design. So in order to ensure that life is safe in a design process, because after the design process the building will be constructed. So when a building is constructed using some design recommendation, the codes would like that this building is safe. So for this purpose, codes are documents which make sure that the minimum life safety criteria has been achieved. Finally, we will be studying the mechanics of reinforced concrete. And this is important because every time when we will start a design problem, we would need exactly what is going on inside the member, in the depth of the member, along the length of the member, what is going on inside this. And your background in mechanics of material and structure analysis and strength of material will help you understanding this mechanics of material. So we will be now directly applying your knowledge of mechanics of material. We will not be going into the details of our derivation of the equations. Okay, the objectives of the course are, as I said earlier, you will be able to see what reinforced concrete is in the course, and then you will also be able to differentiate between different design methods. The objective of the course. The objective of this course is, as I said earlier, that humans need construction of civil engineers, such as buildings, bridges, and dams to fulfill their various needs. Buildings are needed by humans historically to save themselves from weather conditions and to have the privacy and other things. Okay, so from the environmental effect to safeguard the life of humans against the environmental effects, buildings are constructed and bridges are constructed to connect two points. Dams are constructed to store water and produce electricity. These are various needs of the humans. And for these human needs, we need civil structures. Civil structures are buildings, bridges, dams. These are called civil engineering structures because they directly benefit the humans. And now, an engineering design would ensure that these structures are built safe and economical. So when we need structures, we need now engineers to design these structures. The design objectives are two. One, that these structures shall be safe, and other is they shall be economical. Economical means that we should not spend too much money on the design, too much, which is not needed. And they should be safe. Safe is very obvious. But again, safe is not an absolute word. It is a relative word. So safety will be determined. Safety will be determined by engineers that what safety is needed. Because if you compare and if you see the structures which have been constructed around 100 years ago or even more than that, you would have seen that the structures are very, very huge structures. The structures are very huge structures, so they are safe. They are safe, so safety was there in all those structures, according to the understanding of those masons which constructed those structures. But they were not economical. But they were not economical because economy was not a prime objective at that time. They were interested in constructing structures without engineering knowledge. So a difference in the engineering design and non-engineering design is that engineers exactly calculate and they exactly know in terms of values, numbers 1, 2, 3, 4, 5, that how much my structure is safe and how much it is economical. But a non-engineering design cannot tell you these things. Okay, then when we talk about the design, we need material to use in the construction in our design of structures. And generally, materials which have been used over the past several centuries are stones, bricks, timber, steel, and concrete. A very new material has also been used in the last century to construct these structures. In this course, however, our scope is limited to concrete only. We will not be talking about brick structures. We will not be talking about stone structures. You must have seen in some hilly, high altitude areas, houses and buildings constructed of stones, mostly 2 stories or 1 story. And you would have also seen many structures built by using bricks, and timber structures are also used in some hilly areas, but their use is now abandoned because of the government policies. And steel structures, though are not very common in Pakistan, but they are very frequently used in some countries like Japan and USA, especially for high-rise buildings. Okay. In this course, however, we will be studying the basic concept of the design of buildings, bridges, dams. It will not be discussed made of reinforced concrete. So our scope is limited to 2 things. One, we will be studying buildings or building components, design of building or building components, and the material will be reinforced concrete. So buildings made of reinforced concrete will be our topic in this course. Bridges, dams will not be discussed in this course. Although if you study this course, then you will be able at some later stage to understand the design of bridges and dams, because this course is the basic. This course will enable you to develop your basic concepts in design. So once you understand those basic concepts at some later stage, you will be able to understand the design of bridges and dams. Okay, but in this course, we will not be discussing the design of those civil engineering structures. We will be only discussing the design of building components and made of reinforced concrete. Now, what a reinforced concrete is? As I said earlier, that concrete is a material composed of cement. Cement is a binding material, sand and coarse aggregate. Water is added to make a paste from cement, and then this paste will bind together sand and aggregate and will form a stone-like material, which is called concrete after hardening. And I also said that concrete is good in compression but weak in tension. And the tensile capacity of concrete will be enhanced using reinforcement. Reinforcement will be in the form of steel, and in the steel, it will be steel bars. So steel bars will be used for reinforcement in the reinforced concrete. Okay. Primarily to increase the tensile strength of concrete. Okay, next I will show you a video, and you watch this video carefully because different steps of the construction have been shown in this video, and you should note down what are the important steps of this video, and the reinforcement is shown, different members are shown in the video. This video has been downloaded from the internet. So if you go to the internet, some websites are there which will help you in understanding the basic concept of this course. If you come across any useful video, you can share that video with us, and we can also make it part of our lecture. This video which we are going to share with you today was also shared with us by a student like you. So this is a very useful video because at this stage in the beginning, you will not be able to understand many important activities which are associated with the construction of reinforced concrete frame structures. So I am going to start this video. You watch this video carefully, okay? And after the video ends, we can discuss it further. This is basically excavation from the site. I hope all of you can see the video. This is farm work made of wood. Okay, wooden farm work. After the video, if you have any question, you can ask your questions. Okay, the foundation in the form of isolated column footing is being completed. The columns are erected now, and the concreting is also done in the farm work. You can see now the columns completed. This is a farm work for the slab and beams. Farm work. You can see the slab and beam farm work. The reinforcement of the beam and slab has been done, concreting also done. In the next part of the video, you will be able to see the close-up view of this reinforcement. So you should wait till that moment. This is the next story of reinforced concrete frame structure. Next story, this is the roof. So structure is completed, frame structure without walls. Walls will be constructed later. Now, close-up views. Look at the close-up view. This is the reinforcement the foundation excavation for isolated footing and concrete. Farm work. Reinforcement. You can see reinforcement in the foundation, isolated footing, in the column. Column reinforcement is going into the foundation and properly anchored to the foundation concrete. You can also see vertical bars and the square bars, which are laid laterally. Now you can see the farm work, wooden farm work. Inside we have reinforcing bars, steel bars, longitudinally as well as laterally. Now concrete is poured inside this. You can see concrete pouring. Concrete is finished. The lateral bars are called as ties, lateral ties. You can also now see the beam reinforcement. Concreting in a further close-up view will also be shown to you now. Further details of reinforcement details. Now this is a beam column joint, and this is a beam column corner joint, because both the beams reinforcement are terminating inside the column. You pay attention to the reinforcement of beam going into the column, to the far end of the column, and then there is a bend. This is another junction, which is basically an edge column. An edge column, one of the beam is passing through the column, another beam reinforcement terminates inside the column. And in the beam, we've also longitudinal reinforcement and lateral reinforcement. These lateral reinforcement in beams are called stirrups, and in this lateral reinforcement in the column is called as ties, lateral ties. This is a central joint where both the beams running in both directions are going through the column. This is a top floor corner. The column reinforcement also terminates now. The column reinforcing bars also terminates, and they terminates and bends in the beam, and the beam reinforcement terminates inside the column. When we say that we will design beams and columns, as I said earlier, we will be determining the size of these beams, width and depth, and also the reinforcement, longitudinal reinforcement and transverse reinforcement in the form of ties or shells. Okay, next we will discuss types of buildings. There are basically three types of buildings depending on how the load is transferred to the foundation. One of the building types is a frame system. In a frame system, you will see in the next slide, the load is transferred from the slab to the beam and to the column, from the beam and then to the foundation. On the right, you can see a figure of a high-rise building. This is basically a 3D view of a Silk Executive Center in the board which we have designed near the Dean Towers in the board bazaar. This building is now completed and occupied. Next are those buildings where there are walls, like our residential buildings, houses, and these are load-bearing wall system. The load from the slab is transferred to the wall and from the wall to the foundation. And in mixed system, you can have both frame and load-bearing wall system. A frame system, as you will see in this animation, if it is a reinforced concrete frame building, so it will consist of slab, beams, and columns. You can see these are columns. I hope you can see my arrow. This is a column, and these are beams beneath the slab, and you have a slab here. The loads from roof or floor slab, because you see, you should pay attention to this. It will be the roof or floor slabs which will be occupied by the occupants. The beams and columns cannot be occupied. They will carry the load of the slab, and they will help transferring this load to the foundation. So the loads from the roof or the floor slabs are transmitted to the foundation, either directly through columns or through beams to the columns. So sometimes it is possible that there are no beams and the slab is directly resting on columns, but columns will always be there. Columns will always be there because column will transfer this load. So if I click on this and you slide, you will be able to see the animation. This is the load from the slab, okay, and then this load from the slab goes to the beams, and from the beam the load goes to the columns, and through the column the load goes to the foundation pad, and from the foundation pad it is transmitted to the ground. And the ground in turn will apply a pressure, upward pressure on the foundation, and the foundation will be bent upward at the edges. And for this purpose, the foundation must be designed in order to resist this upward pressure. Okay, so it will be the foundation, particularly in this case, as shown in this slide, is like an isolated footing, and the foundation will be bent at the edges, and the bending moment will be such that tensile stress will be produced in the lower part of the foundation pad, and compression stress will be produced in the upper part of the pad. So and it is possible to design structures without beams, where the slab will be directly resting on column. It is possible. In frame system, the reinforcement in a frame system, the reinforced concrete design is carried out component by component, such that slabs, beams, and columns are separately designed. So slabs will be designed separately, beams separately, and columns separately. In a load-bearing wall system, which is a typical residential system, you would have seen many houses made of brick masonry. You would have also seen brick masonry walls in a frame structure. But those brick masonry wall in a frame structure, they do not take load from the slab. They are just partition walls or non-load-bearing walls. You should remember this. In a frame structure, the walls are only provided to provide partition. To provide partition, they are called non-load-bearing walls. They do not take any part in gravity load transfer from the slab to the foundation. Okay, you should remember this. They are just partition walls. But in the load-bearing wall system, which is a very common system that we use in our houses, the slab directly rests on the walls, and the wall transmits load from the slab to the foundation, and from the foundation pad it goes to the ground, and as I said earlier, the ground will in turn push the foundation upward with the upward bearing pressure. So if I click on this slide, you will see the animation of one of this wall, which basically. So all other walls also, all other walls attached to the slab will take the load from the slab and will transmit it to the foundation. If there are openings, so across the openings, a beam must be provided. Like in this position, if you can see my arrow, this is an opening. So there at this location, a beam must be provided. A beam must be provided. That beam will take this load and will transmit on both sides of the openings to the walls, because the load cannot be transmitted through this opening. There is no connection. So across this opening, a beam will be provided on top of the opening, and the slab will transfer load to the beam, and from the beam, the load will be transmitted on both sides of the opening to the wall, and from the wall it will go to the foundation. So in this way, the load will be transferred. This is called as load path or load transfer mechanism. Okay, load path or load transfer mechanism. This is very important to understand. We are not going into the detail of this load transfer mechanism or load path. Slowly and gradually, you will learn these things. Okay. Then we can have a mixed system where frame structure and load bearing wall system will exist side by side like this thing. You can see also a wall, but this wall, which is provided between the columns and the beams, is called an infill wall. This is just to fill the space, and provide provide a partition wall. So this infill wall basically will fill this gap wherever required, but this will not take any load from the slab. This will just be acting like non-load bearing wall. This is called non-load bearing wall, an infill wall, and also called as a partition wall. Maybe constructed of brick masonry or blocks or even stones or some other material, depending on the situation. And then we have a load bearing wall system where the slab load will be transmitted to the brick masonry wall, and from the brick masonry wall to the foundation. Okay, next topic is on the load effects on the building. Whenever a reinforced concrete frame structure, because as I said earlier, in this whole course of reinforced concrete design, we will be discussing frame structures. In frame structures, there are slabs, beams, and columns. And beneath the columns, there is foundation, isolated foundation, or some other type of foundation. We will be discussing different components of reinforced concrete frame structures, not a load-bearing wall structure. Okay. So let's see. In a 3D view, you can see a 3-dimensional structure with slabs and beams and columns, and you can also see when the slab is loaded. The gravity load or the self-weight of the structure is also a load. So under its self-weight or some other imposed load, when the structure undergoes deformation, then different type of stresses will be produced in the different parts of the structure. In the beams, as you can see, mostly flexure stresses and shear stresses will be produced. In the column also, you can see flexure and shear stresses will be produced. In the column, axial compression will also be produced, because the column is vertical and the slab and the beams are horizontal. So this horizontal load will be transferred vertically to the column. So this column will also resist some axial compression. Okay. So column will be subjected to axial compression, but the flexure stresses will also be the column will also be subjected to flexure stresses and also shear stresses. A column will be subjected to axial, flexure, and shear stresses, and beams will be subjected to flexure and shear stresses. And torsional stresses are also possible. Sometime, if a member is subjected to torsional stresses, you will see in the next animation how these different type of stresses are produced in different components. Okay, I will now share with you this animation. You can look at this animation. During the animation, you can see how the beam bends and the flexure stresses are produced, shear stresses are produced in beams and columns. Okay, from this animation, you will be able to see. Okay, next I will share with you another video which we have again downloaded from the internet, but this is very useful in the understanding of basic concepts of stresses. Okay. In the first animation, there is a steel bar, or let's say that this is made of concrete and it is being pushed inward. So this pushing inward will tend to shorten the length of the member. And also you can see slight bulging from the center of the member due to Poisson effect. Okay, you can also see now the tensile stresses. This is the stretching of the member, which is now causing a decrease in the diameter of the member, or the area of the member at the center of the member. Okay. So this is tensile. This is called power pulling. This is now a beam subjected to flexure stresses by a point load. You can see tensile stresses are produced in the lower fibers and compressive stresses are produced in the upper fibers. So we need to reinforce the lower part, not the upper part. This is flexure stresses. Flexure stresses are those stresses which are produced in a member, which when compressive and tensile stresses are produced side by side, remember they are called flexure stresses or bending stresses, because they are produced due to bending. You can see now torsion stresses being produced in a member. If such effects are produced in a member, they will induce torsion stresses in the member, and the member must be designed against these torsion stresses as well. This is a shear phenomena, where one part of the member slides against another part. Okay, our next topic is what a structural design is, and what are our objectives, and what topics will be needed to understand structural design. The structure must be designed to withstand all these effects without undesirable consequences. These effects mean the previous effects, which are axial compression and axial tension, flexure stresses, which consist of compressive stresses and tensile stresses, shear stresses and torsion stresses. So all these four types of stresses might be present simultaneously in a member, or a couple of these might be present, or three of them, or one of them. Whatever the situation is, the member must be designed against all these effects. Okay, and to design the member against all these effects, the magnitude of these effects must be determined. And once the magnitude is determined, then the reinforcement in the form of bars, longitudinal, or lateral ties and strips will be calculated, and the size of the member will be fixed or determined to design the member. In order to learn the design of reinforced concrete buildings, following topics must be needed to understand. Number one, properties of concrete and reinforcing steel. Then the building codes used for the design of reinforced concrete and mechanics of reinforced concrete. These three topics must be understood very well to understand the concept of the design of reinforced concrete buildings. First of all, we will study the properties of concrete and steel. And out of these two, we will first study the properties of concrete. And in all the properties of concrete, the compressive strength is the most important property of concrete, because the compressive strength of concrete is considered as an indicator for all other properties of concrete. An indicator means that if compressive strength is good, then all other properties of concrete will also be good. Indicator, it is used as an indicator. It is one of the most important property of concrete, the compressive strength. And the compressive strength is measured by a compression test of a standard test cylinder. This test is used to monitor the concrete strength for quality control acceptance purposes. So now let's say you are working in a project in some city, and concrete is being poured in the beams and columns, and you are a site engineer over there. So how will you check the quality of concrete? You will check the quality of concrete by taking samples of concrete cylinders from concrete, and then covering those concrete cylinders for 3 or 7 days, and then testing it in a lab. And after you calculate the strength of the cylinder, you can compare the strength of the cylinder with what has been specified for the project. And if the specified strength of concrete for the project is equal to the strength of the cylinder that you have determined in the lab, then it says that concrete passes the criteria. However, if the cylinder strength is less than the specified strength, which has been specified for the concrete in the project, then we will say that concrete has failed. concrete has failed and it has not achieved its compressive strength. So in this manner, you can see, you can check the quality of concrete at a site. Okay, you know that I hope you would have already conducted or done a test on a concrete cylinder. If not, you can do this very easily. Every day we receive tens of samples in our concrete lab. You can go to the concrete lab, material testing lab, and you can ask the in charge of the lab about the testing of cylinders. So they will give you a proper time where they will be testing cylinders. So you can watch this testing of cylinders. Okay, I can also show you a video of a testing of a cylinder. The ASTM standard C31 and C39, they cover this testing, because you know that testing cannot be done arbitrarily or to the choice of a person. Testing must be done according to some protocols. And these protocols are given by the ASTM, American Society of Testing Material Standards. You must have to test your sample according to the ASTM criteria. Okay, this is a stress strain curve, a typical stress strain curve for a cylinder. You can draw a typical stress strain curve for a cylinder. Okay, when the load is applied on the cylinder, then the stress is load divided by the this circular area, pi by 4d square. So load divided by this area will give you stress, and the strain. If you are able to measure the deformation of the cylinder, then the change in deformation divided by the total length of the cylinder will give you strains. You can plot the stress versus strain on a graph paper like this. Okay, you can see this is a typical stress strain curve for a cylinder having a strength of 4500 psi. If you look at this curve on the left, in the blue line, basically the peak of the blue line is at a value of 4500 psi, and the strain corresponds to this is around 0.0022 or something like this. Okay, so the concrete peak is at a strain of 0.002 or near to 0.002, and the strength is 4500 psi. And the final downward branch of this curve ends at a strain value of 0.003. Okay, you can also see the different curves on the right now in magnified view of this. These are different curves for 2,300, 3,000, 4,000, 5,000, 7,000, 8,000 psi concrete, and there is a peak of this, and then there is a downward branch of this curve for every cylinder. And you can see that invariably the strains are from 0.002 to 0.003 to 0.004. So they are the ranges of strains from 0.0025 basically to 0.004. These are the strain values, and the strength varies depending on the constituents of the concrete, because generally with the increase in cement content, the strength will increase. But there are many things which must be kept in mind while designing, while proportioning the concrete constituents for a high strength concrete. Okay, next I will show you a video which is a test on a concrete cylinder. The stress strain curve and the test of the cylinder both are shown side by side. The cylinder age is 4 days. The concrete age is 4 days. So you can see 4 days early age concrete. You can also see that in the beginning, the strength and strain are linearly proportional, because it is a straight line. So in the beginning, the stress is linearly proportional to strain. But with further increase in load, then the linear relationship ends in a non-linear relationship in the form of a curve is shown. So up to around 50% of the strength of concrete, the relationship is linear. But after that, the relationship becomes non-linear. You can see the final value of strain is 0.0024, and the strength is around 2700 psi. Okay. Okay, we were talking about the compressive strength. Now talking about the tensile strength. Although tensile strength is not usually required to be determined in a reinforced concrete structures, there are some situations in which tensile strength needs to be known to us or determined. So it is better to know what ASTM standard governs this standard test. ASTM C293 basically covers the tensile strength of concrete, and this is called a standard test method for flexure strength of concrete using simple beam with center point loading. The beam is 6 by 6 inch in size, 6 inch wide, 6 inch deep, and 30 inch long, and it is subjected to a point load in the lab. You can do this test very easily. If you are interested, you can come to the lab, talk to the lab in charge, prepare a simple 6 by 6 inch and 30 inch long, and test it in the lab, and you can determine the tensile strength of concrete by the equation shown below the beam figure. Okay, this is Fr is equal to 6m divided by BH square. M is the bending moment at the center point, because if there is a point load on the center, so the maximum bending moment will occur also at this location. So maximum bending moment can be calculated, because when you test the sample, and mind that this is made of paver concrete, not reinforced concrete, paver concrete, only concrete without reinforcing bar. So when you test this, you can determine the load P, and from the load P you can calculate bending moment, because in a simply supported beam subjected to a point load, M will be equal to P L by 2. So the bending moment can be very easily calculated, P L by 4, and BH square are the dimension of the beam. So Fr is equal to 6m BH square can be calculated. This Fr is basically the maximum flexural tensile strength of concrete, determined through this test. And this maximum flexural tensile strength is also called as modulus of rupture. Modulus means measure, and rupture means failure. So this will be the measure of failure of a pure concrete beam, only concrete, no reinforcing bars. Generally speaking, the tensile strength of concrete is 8 to 15% of its compressive strength. Okay, if you have a chance to plot for same concrete its tensile strength against its compressive strength on x-axis and y-axis, so you will see that there is no direct relationship between the compressive and tensile strength. But if you take square root of Fc prime, the compressive strength, then you will have a very good relationship between the tensile strength and the square root of compressive strength. This is a practice which is usually done in research, in research by researchers. If you want to make a relationship between two variables, sometimes direct relationship between the variable is not possible. For example, if you want to plot, if you want to test concrete from same sample or from same concrete, if you prepare cylinder of concrete and you prepare beams of concrete, and side by side you check you calculate the compressive strength and tensile strength. Because the values are calculated from same concrete, you can plot the compressive strength, let's say, on x-axis and the tensile strength on y-axis. And now, if you want to develop a relationship between the tensile strength and compressive strength, so you can do so by fixing a curve between the tensile strength and compressive strength. However, if you do this, you will not be able to have some meaningful relationship between tensile strength and compressive strength if they are directly plotted. However, if you plot tensile strength directly and compressive strength is a square root of Fc prime, and then plot the values on the graph, you will be able to see a very good relationship between the tensile strength and square root of compressive strength. And this is a methodology which is adopted in research to develop relationship between two variables if direct relationship is not possible. And that relationship is now very well established, and tensile strength is directly proportional to FC prime square root, not direct FC prime. Okay, before we go to the next slides, we will take a little break of 10 minutes. Okay, and after 10 minutes, we will resume our lecture. Okay? Thank you. Okay, we'll shortly resume the lecture, so you should inform the students who have left the class that they join us again, because shortly we are going to resume the lecture. Inform the students, please.
Okay, sir.
Okay, so let's resume the lecture. We, before the break, were talking about the reinforced concrete, and we said that concrete is weak in tension. You will need reinforcing concrete using steel to enhance the tensile capacity of concrete. What form of steel and what type of steel will be used for this reinforcement? This we will be discussing now. There are four different types of reinforcing steel according to the shape in which they are available and the strength they are available. There is a deformed bar reinforcement. This is the most common bar that you see every day in the construction projects. There are projections around the bars. These are called deformation, and this deformation on these projections, basically they will help the bonding of steel bar with concrete. Several years ago, plane reinforcement was also used as reinforcement, but now this the use of plane reinforcement is almost abundant, because the bonding of plane reinforcement, which means plane reinforcement is the reinforcement without the deformation on the bar, which will help good bond between steel and concrete. These projections or deformation on a plane reinforcement are they do not exist on plane reinforcement, so it is plane reinforcement will not bond very well with concrete. So for this purpose, plane reinforcement, the production of plane reinforcement is abundant. Then we have pre-stressing steel type of concrete called as pre-stressed concrete. This we will discuss some other time. And then we have structural steel shapes in the form of girders, I, T, and wide flange sections, which is used in steel structures. We will not be using the three plane reinforcement and pre-stressing steel and structural steel shapes in this lecture. We will only be using deformed bar reinforcement. So in the next slide, we will be only talking about the properties of deformed bar reinforcement. This is the general typical shape of bars. On the left, you can see a bar with the horizontal and vertical ribs. These ribs, as I said earlier, are projections, deformation. These ribs basically help the bonding between steel and concrete. Then sometimes there are some letters written on the bars. The letter H usually indicate the symbol for producing mill or the factory name. The number basically tells us the diameter of the bar. If, for example, if it is number 11, so it means it is 11 by 8 bar. 11, the diameter is 11 by 8. And S means the type of steel. S basically refers to steel which conforms to ASTM A615. ASTM A615 is a standard which provides us specifications or properties of this type of steel. Okay, and on the right you can also see another mark which is 60. This is a grade mark. This is grade 60 steel. We will see this in the next slides in detail. Okay, there are two specifications. A specification, what is a specification? Specification is basically a set of good properties. It is a set of good properties. What properties should be there in a steel if it is ASTM A615. So ASTM A615 is the name given to a set of properties or a set of good properties to a steel. In other words, for example, if I tell you that this is a steel bar, so the next question would be, what are the properties of this steel bar? So this steel would have some set of properties, not one property, like its compressive strength, tensile strength, its yield strength, its ductility, its strain, and all these things. So this set of properties is given a name, and this name is given by ASTM. And for example, if it is ASTM A615, then ASTM A615, if you study this ASTM A615, there will be a list of properties that a steel would be conforming to ASTM A615 when it has these following properties. I hope you understand this now. In other words, I will try to explain this further, that if a steel bar, if you purchase a steel bar from the market, and the people who are dealing in the steel business, they mostly are unaware of these different standards. Okay, so for example, if you are an engineer and you are working on a project, and the designer has specified a particular steel. By this I mean to say that the designer says that the steel should have a tensile strength equal to this, its ultimate strength equal to this, and its yield strength equal to this. So these are the list of properties. Okay, and you go to the market and purchase a steel bar. So you are unaware, completely unaware, whether the steel bars have these specified properties or not. So what you will do, you will come to the lab, you will collect samples and test it in a lab, and then you will see whether the specification are fulfilled or not. If all those specifications which are mentioned by the designer are being fulfilled, so you can say that this steel bar fulfills the specification set by the designer. Okay, now the designer, instead of listing the specification, will use just one word, that with whatever steel you use in this project should conform to ASTM 615. Okay, so instead of listing the properties, he will give you this standard ASTM A615, and then you will go to the ASTM A615 and will see what are those properties which this steel should conform to or should fulfill. So then the ASTM, the designer will just write one word, that the steel should conform to ASTM A615. And then when you test the steel bar in the lab, in one hand, you will have ASTM A615 specification. In the other hand, you will have the result of the steel bar. You will compare the two, and if they match, then you can say that the steel conforms to ASTM A615. I hope you understand this now. ASTM A615 basically covers the deformed carbon steel reinforcing bars. You should remember this if you have ever studied the manufacturing of steel produced in a factory. So the steel gets its strength because the steel is an alloy made of iron, and you have heard the name blast furnace and other furnaces in which the steel is manufactured. During the manufacturing of steel, the strength of steel is achieved by adding carbon to it. So when carbon is added to iron during the manufacturing of steel, it will increase the strength, but it will decrease the ductility of steel. So generally the steel bars which are available in the market, they are carbon steel and they conform to ASTM A615. So mostly the steel available in the market is ASTM A615. It is called carbon steel because the strength comes from addition of carbon. You can go through some of the relevant documents or videos available on the internet if you are interested more in the manufacturing of steel in a factory. You will be able to see that steel strength is achieved by adding carbon to the iron, and but it has a limit. The carbon addition has a limit. After that, if you add more carbon, then although the strength may be achieved, but the ductility will be lost, and we would as engineers, we would like our steel bars to have strength and ductility both. Because if steel is very, very brittle, then the structures which we made of steel, which we construct from steel, will be very, very brittle, and it will collapse, and break without giving any warning. So we would like the steel which we use in our construction to be ductile instead of brittle. We have good strength, but ductile. Okay, so the general steel is A615. This steel is readily available in the market, and almost all factories in Pakistan, they produce ASTM A615. Pakistan has a very good steel industry, and the steel produced by Pakistani industries, they conform to ASTM A615. We have tested steels in steel bars in Pakistan in our university at UET Peshawar. Every day you would have seen we test a lot of samples, and most of the sample they pass the criteria of ASTM A615. There is another type of steel. Which conform to ASTM A706. These will be the manufacturers. These will be the manufacturers who will decide what type of steel they want to produce. If the manufacturers want to produce ASTM A615, then they will produce ASTM A615 in such a manner that they conform to ASTM A615. And if they intend to produce ASTM A706 steel, which is superior steel, ASTM A76 is a superior steel to ASTM A615. Due to its properties of more ductility than the ASTM A615 and more weldability, ASTM A706 is a costly steel with superior properties. It is a special steel, and it is not used in every project. It is used only in special projects where the weldability is required, or where rusting is a concern. So in order to avoid rusting of steel, ASTM A706 is used. ASTM A706 has been historically used in nuclear power plants and in areas where there is a lot of exposure of reinforced concrete structures to chemical attacks. However, in Pakistan, this steel was only used in some of our special facilities in the Atomic Energy Commission. But now this ASTM A706 is used in some of the factories in Pakistan outside the Atomic Energy Commission. But mostly we'll be using ASTM A615 because ASTM A706 is costly steel, and we will recommend using this steel only in special projects. This slide number 27 is very, very important for you. On the top of this slide, I will show you ASTM A615 very quickly. You can get hold of this from the internet. You can download this ASTM A615, wherein you will be able to see the properties of. So this is the standard. I will magnify this a little bit so that you can see this clearly. This is ASTM A615 standard specification for deformed and plain carbon steel bars for concrete reinforcement. This is the name of this, scope and everything is given in this. You can study this later. If you look at the name of this, it said standard specification. Standard specification. And I said earlier that specification means properties, like good properties. What should be the standard properties, in other words, for deformed bars? These are the properties which should exist in a bar that you would like to use in concrete, reinforced concrete. So if we go through this quickly, these are the different properties, bars. This is the terminologies. It has the chemical properties, tensile requirements, measurement of deformation, and all this. You can go through this yourself. Just wanted to share the standard with you so that you can see at least what the standard is. Okay, on this slide now, there are 4 columns. In column number 1 to the left, the name of this column is bar designation. We will be frequently saying in our design that we are using number 3 bar. So this H is basically number. H by H we means number. So H3 means number 3, H4 means number 4, H5 number 5, H6 number 6, and so on. H3 is number 3. What a number 3 bar is? Number 3 bar has a diameter equal to 0.37, and 0.37 comes from 3 by 8. Number 4, 0.5 comes by 4 by 8. So every number divided by 8 will give you the diameter of the bar. Every number 3, 4, 5, 6, 7, 8 divided by 8 will give you the diameter of the bar. Okay. Number 4 bar divided by 8. 4 divided by 8 is half 0.5 inch. These are the diameters. So these diameters are given. So you should remember, and you should always remember this in so that you can use them easily. Okay. Whenever I ask you, you should remember and tell me just on fingertips that what a number 4 bar stands for, what is the diameter of the bar, what is the area of the bar, area of steel, and what is the weight of this steel bar per foot. These are weight per foot. So let's say we say that number 4 bar. So for number 4 bar, the diameter is 0.5 inch. The area is 0. How the area is calculated? Pi by 4 d square. Pi by 4 into 0.5 whole square will give you this 0.2 square inch. You can do this easily, okay, like this. If you calculate this, pi by 4, pi divided by 4 d square. You know pi is 22 by 7. So this is multiplied by 4 into 0.5 whole square. You calculate this yourself and tell me what is the value.
$0.196.
0.196. 0.196. Okay, it is 0.196. But as you have seen that there were ribs also on the bars. You've seen the ribs, okay? So because of these ribs, we will round this to 0.2 because ribs were there. And ribs are not calculated in this diameter because the actual diameter is 0.5. With the ribs, we round this to 0.2. So a number 4 bar has an area of steel equal to 0.2 square inch. Correct? In the same manner, you can calculate area of steel for every bar. Okay? Okay, the weight can also be calculated very easily. Let's say we calculate the weight for number 5 bars. Number 5 bars. Number 5 bar, how can we calculate this? The weight of number 5 bar is 1.04 pound per foot. Okay, we can do it like this. For 1 foot bar, because you see, this is important. If you want to purchase steel from the market, so you will order steel in terms of weight. That this much of kg, this much of ton of steel is required. So you will purchase steel in terms of weight. So it is also necessary that you know the density of steel and the weight of steel per foot. So by knowing the weight of steel per foot, if you can calculate the length of steel bar being used in a project, you can calculate the weight easily. Okay, the weight is calculated in this manner. You know that weight of a material is calculated from its weight density gamma into the volume, because this gamma is in pound per cubic foot and this is in foot, so you can calculate the weight. Okay, for 1 foot length of a steel bar, this is 1 foot, 12 inch, and it has a diameter D and area A. So this will be like this. Gamma of density. What is the weight density of steel? Anyone from you? Anyone? It is 490 pound per cubic foot. The density of steel is 490 pound per cubic foot. And the volume of steel will be area into the length. Area into the length. Okay. And area is pi by 4 d square. Pi by 4 d square. Okay. So for number 5 bar, if you calculate pi by 4 d square yourself, tell me the area of number 5 bar. Number 5 bar has a diameter equal to 5 by 8. Dia equal to 5 by 8. Okay, tell me the area of number 5 bar.
Zero point 5.
0.5. Do it again.
0.3, sir.
0.3. 0.3 is correct. 0.3 square inch. It is the area. Okay. Now multiply this 490. It is pound per cubic foot. Pound per cubic foot. And the area is in inches. 0.3 square inch multiplied by 12 inch. We have to convert these into feet because we have feet in denominator here. So this must be divided by 144 and 12. This 12 will be cancelled with this. And now you calculate this weight. 490 multiplied by 0.3 divided by 144.
1.02.
1.02 pound per foot. So 1 foot of number 5 bar has a weight equal to 1.02 pound. Okay. There is another equation which has been derived from this equation, and you can derive this like this. Okay, general equation for this. Now look at this general equation. W is equal to, pay attention to this, 490 into area, which is 5 by 4 d square, into 1. 1 is foot, 1 foot. This is 1 foot. Okay, and pi by 4 d square, if d is, this is pound per cubic foot. Let's say d is in feet. So you can calculate this. Tell me, simplify this and tell me. Okay, no, let's say the d if we take d in inches, then we will divide this by 144. We'll divide this by 144. So tell me about this equation. What is the simplified version of this equation? Because the only variable in this is now d.
Sir, 2.67 multiplied by d square.
2.67, correct. And 2.67 in terms of 2.67 is equal to 8 by 3, isn't it? .67 is 8 by 3, correct? Okay.
Yes.
2.6 is 8 by 3, correct?
Yes, sir.
Okay, so it means that you can calculate the weight of 1 foot of steel by 8 by 3 d square. Now you can do this again. D equal to 5 by 8 or 5 by 8 whole square multiply by 8 by 3, you will exactly get the same answer. Pi by 8 is the diameter. Pi by 8 is the diameter of the steel bar, our number 5 bar. D. D is equal to how much? 5 by 8. 0.625.
0.625.
0.625. 2 times multiply this into 8 divided by 3. 1.04 pound per foot. So it is the same. You can directly calculate weight of the steel bar from this 8 by 3d square instead of going into gamma, V and all this. If you know the diameter of the bar, so for 1 foot of steel bar, you can calculate the weight from this equation, correct? Okay?
Yes, sir.
Now we can move ahead.
Yes, sir.
So this table is very important for you because very frequently we will be using these bar designation, diameter, areas, and weights. So you should remember these on your fingertips. Strength of steel bars. Currently in Pakistan, 2 types of steel bars are available. Steel grade, when we say that it is steel grade 40 means that the yield strength is 40 KSI and the ultimate strength is almost 70 KSI. And in Pakistan, grade 60 is also available now. And it's when we say that steel grade is 60, the yield strength of the steel is 60 KSI and the ultimate strength is around 90 KSI. And 50 and 75 steels are not produced in Pakistan, although they are available elsewhere. In Pakistan, some factories, especially the Mughal steel, they have started production of grade 70 steel. 70 KSI. And we have used this grade 70 steel in one of our projects, which I was talking about in the beginning. That is the Diamond Mall on the University Road, 70 KSI steel we have for the first time used in our projects. This is a typical stress strain curve for steel. I will not go into the detail of this stress strain curve because I hope you have studied this several times in your different subjects. There is a typical, the solid line basically shows the actual curve of steel stress strain curve, which you can plot from a stress strain test, from a pull test on steel bar. You can draw and plot this curve. The solid lines show the actual curve. And the dotted lines show the idealized curve. You should remember this. This is very important to note that the maximum strength of steel that we will be utilizing in our design is the yield strength, not the ultimate strength. So whatever the ultimate strength of the steel bar is, regardless of that, we will be using its yield strength as the maximum strength that is to be utilized in our designs. Okay. So, for example, a steel bar has an ultimate strength of, let's say, 80 KSI, but if it is a yield strength of 60 KSI, we will use 60 in our calculation instead of 75. Although the steel has a capacity from 60 to 75, this has been determined from the test. But this remaining capacity from 60 to 75 will be kept as a reserve capacity. This will also give us a factor of safety, and this will also ensure that the steel fails in a ductile manner, and the building, when fails or collapses, will give us a degree of warning, so we can evacuate the building well in advance. So for the purpose of having a ductile mode of failure, which is a desirable mode of failure, and to have degree of warning for the life safety, we would only utilize the yield strength of steel and keeping the remaining strength of steel up to the ultimate as the reserve strength. Okay, and you also know that from the yield to ultimate, the steel undergoes a lot of deformation. You can see this from yield to ultimate, the steel undergoes this much yield. And this yielding is basically, this is a measure of ductility. I hope you would have heard the name strain ductility. Strain ductility is basically the ultimate strain at which the steel finally fails and the yield strain. So this is, for example, if it is the ultimate strain and this is the yield strain, the ratio of this will give us a measure of ductility, strain ductility of the steel. So the larger this gap, or the larger this ratio, the better, the higher the ductility of the steel will be. So the strain ductility is a measure of the of a better performance of steel, because ductility is a desirable property of steel. We would like to have ductility in our steel, okay, in our the steel that we use in our projects. So two things we should remember from this slide. One, that yield strength will be used as a strength in our calculation, not the ultimate one. And the remaining strength will be kept for the purpose of ductility as a reserve strength. Okay, next part is about the codes. A code, as I said earlier, is a set of technical specifications. Specification, again, technical properties. A code is a set of technical specification or properties and standards that controls the important details of design and construction. The purpose of code is to produce sound structure so that public will be protected from poor and inadequate design and construction. In the beginning, if you remember, I said that if I give you a design problem, every student will come up with a different answer. So that is good and acceptable in design, but as long as all the answers are within certain limits, and those limits are defined by codes. And codes want to make sure that life is safe. There are types of codes. General building codes are those codes which address all the different requirements of the building. For example, architectural, structural, mechanical, electrical, etc., etc. This is a general building code and called as mother code. And this mother code or general building code will address all the requirement of a building. Okay, and then within the general building code, you can have different codes. For example, seismic codes are only used for the design of building against earthquake forces. So if a code gives you recommendation or provisions for the design of buildings against earthquake forces, it will be called as seismic codes. And we have seismic codes like CO, Blue Book, NIHRP, and BCP SP 2007. CO, Blue Book, and NIHRP, these are American codes, and BCP SP 2007 is a Pakistani code. BCP stands for Building Code of Pakistan. BCP is Building Code of Pakistan. And then with the dash SP means seismic provisions that were developed in 2007. And I was part of the development of this code. I was one of the members of this code when this code was developed. BCP SP 07 means Building Code of Pakistan, Seismic Provision 2007. So our code, Building Code of Pakistan, addresses only the seismic provisions. It is not a general building code. For general purpose, we use the American codes. And the recent American code is IBC, which is International Building Code. There are European codes also available, Japanese codes, New Zealand codes. But in Pakistan, since most of us are educated in USA, and we are very well trained in the USA literature, books, and codes are taught in our universities for this, and because the codes of United States are very well written and they have very good standard. So for this purpose, we normally use United States codes in Pakistan. And most of the countries worldwide, they use the American codes. Although the American codes cannot be used as they are in the current form exactly, because every country has its own requirements, and the American codes are then modified according to the local requirement. And exactly this thing we have done for our Building Code of Pakistan. Building Code of Pakistan has been developed from the earlier version of Building Code of American Building Code, which is called UBC. UBC was Uniform Building Code in 1997, and the UBC 1997 code was a little bit modified and called as Building Code of Pakistan to suit our local conditions. There are material-specific codes like steel codes, concrete codes, and AASHTO codes. As I said in the beginning, we'll be using concrete code in this course, which is ACI, American Concrete Institute code. There are some other codes like ASC. ASC is American Society of Civil Engineers. ASC, basically, they have done a lot of work in the loads on the building, different loads on the building. Okay, I have a link to this code, but I am not going to go through the link of this ASC 710. You can download this ASC 710 from the net. This is available on the net. If you don't have a copy of this, my TA can send you a copy of this. Okay, ASC 710 basically addresses the design loads. When you want to design your structures, you must design it for certain loads. What should be the load? What should be a live load for an office? What should be the live load for a school? What should be live load for example, hospital? These live loads have been calculated by ACC1 after a lot of research. They give you a good idea what load should be used in what load should be used as a live load in your specific structure. So this ASC7 gives you this idea. Okay, just to sum up this discussion on the code, there is a general building code, and the general building code, within the general building code, then there are other codes like seismic codes, material codes, and then ASC7. And for example, if in general building code, there is a section on loads. So in loads, the general building code will tell you that you should choose ASC7 for the loads, because ASC7 is a good document. So general building code will not develop its own code. General building code will not develop its own code, because ASC7 is a good document and it is already there in practice. So general building code will tell you that use ASC7 for loads. For example, general building code will tell you that use AACI for concrete. General building code will tell you that use AIC for steel, and so on. Okay, so there will be some general sections in the code, some specific sections in general building code. Okay, and that will tell you for which structure which code shall be used. Now, talking specifically about ACI, because we will be frequently using this term ACI, you should pay attention now a little bit more. Okay, there is a document called ACI MCP. The ACI means American Concrete Institute. MCP means Manual of Concrete Practice. The ACI MCP is a document, is a bulky document, is a huge document consisting of a lot of volumes. Okay, ACI, American Concrete Institute Manual of Concrete Practice, consists of a lot of volumes. This is a one document, but consisting of a lot of volumes. It is available in soft copy as well as in hard copy. The hard copy is available in our library, but I think it is an older version of ACI MCP. The recent version of ACI MCP has been published in 2019. We will be using the 2019 ACI MCP. Now, pay attention. ACI MCP is a document which gives you recommendation and provisions on different topics associated with concrete. For example, within the ACI MCP, you will find ACI 318, ACI 315, ACI 349, and several other reports and codes. So ACI MCP is a mother document on concrete. It is a basic document on concrete. Anything that you want to find on concrete, you can find this in ACI MCP, Manual of Concrete Practice. Everything that you want to find on concrete, you will be able to find in this document ACI MCP. Within the ACI MCP, then there are many reports, many codes inside this. For example, because it is not only buildings, and it is not only reinforced concrete frame structure that you will be using practically. You can design water retaining structures, you can design bridges, and you can design pavements made of concrete. And then within the concrete, there can be several types of concrete, and all these are covered in the ACI MCP. But the code that is specifically used for reinforced concrete is called as ACI 318. You should note down this. Within the ACI MCP, there is a document called ACI 318, which is, if you look at the name of this ACI 318, this is Building Code Requirements for Structural Concrete. So it is this code which we will be using, but this code is part of MCP, Manual of Concrete Practice. ACI 318. ACI 318 says it is Building Code Requirements for Structural Concrete. Structural concrete also covers reinforced concrete. So ACI 318 covers building and concrete, not bridges, not dams, and only reinforced concrete, not other type of concrete. Okay, now talking about the ACI 318 code. The American Concrete Institute Building Code requirements for structural concrete ACI 318, referred to as the ACI code, provides minimum requirements for structural concrete design and construction. Minimum requirements. It's provide minimum requirements. Minimum requirements to ensure that life is safe. The term structural concrete is used to refer to all plain or reinforced concrete used for structural purposes. Pre-stressed concrete is also included under definition of reinforced concrete. So we will be referring to ACI 318 code because ACI 318 is part of Manual of Concrete Practice, and it addresses the building code requirements for reinforced concrete. Okay, this is one of the portion of the code that we copied from the code and presented on this slide, just to make you aware of the language of the code and how the code deals different things associated with the design of buildings. So this, if you look at this name, this says that design loads in the ACI code. What should be the design loads in the ACI code? Then you have a load. This is covered in the ACI 318. ACI 318, as I said earlier, building code requirement for structural concrete. 19 means that this code was last revised in 2019. 2.3 means it is section 2.3 of the code. ACI 318-19 code define load as forces or other actions that result from the weight of all building materials, occupants and their positions, environmental effects, differential movement, and restrained dimensional changes. Permanent loads are, okay, this is up to this. Then permanent loads are those loads in which variation over time are rare, are of small magnitude. All other loads are variable loads. It means that dead load, self-weight of the structure, and any other material which is fixed to the structure for a long time. For example, flooring on the slab, marble flooring on the slab, and other fixtures which will stay for a long time on the structure, they will be called as dead loads. And live loads will be those loads whose position will vary with time. Position and magnitude will vary with time. For example, in a school building, the students in a school, college, or university classroom, the load of the students will be live load, and the weight of the self-weight of the classroom slab and beams and columns will be dead load. And also imposed dead load. Imposed dead load means any other load which is in addition to the self-weight of the structure. For example, a marble flooring on the slab, top of the slab, will be dead load, but it will be imposed dead load, which is called a superimposed dead load. Superimposed, it is not the self-weight of the structure, it is in addition to the self-weight of the structure. Okay, this is the definition of loads. Again, this is section 2.3. You can go through this yourself. This is nothing new, but as I explained earlier, the same thing is being written here. Live loads are those loads which will vary with time. You can go through this. Okay, I will just share with you the minimum uniform distributed live loads in the ACI code from a table. This is the table. This table is being taken from Nelson book. Okay, if you are able to see different types of structure based on their used. For example, office use. For office use, the live load which is required to be used in design is 50 pounds per square foot. And the bracket, it is kilonewton per square meter, and without bracket, it is pound per square foot. For a computer use, for example, you will use 100 pounds per square foot, and all other different type of structures based on the occupancy, purpose of occupancy have been mentioned. And then in front of every structure, the loads are given as uniformly distributed live load. Okay. Other loads include earthquake loads, wind loads, no loads. So the conclusion is that when you start designing a structure, you will need what? You will need loads. what loads shall be considered in this design. There are two types of loads, dead loads and live loads. Dead loads then consist further of two types of loads. One is self-weight of the structure, and the other is superimposed dead load, which is in addition to the self-weight. Then you have live load. Live load is the load of the occupants who will occupy the building, and a guide to this live load can be taken from the ACI table, which I just shared with you. So once the loads are selected, then for this load the structure will be designed. If you do not know what are the loads, because the loads will produce stresses in the structure, the loads will produce bend moments and shear. So the small load will produce small stress, large load will produce large stress. So if you make a mistake in the selection of load, it can substantially affect your final design. Let's say if a load is very high actually, and if you take a small load, so it will put the structure safety at stake. And on the other side, if the load is very small and you take a high load, so you will compromise the economy of the structure. So you should realistically select your loads. This is the conclusion of this part of the load lecture on the loads. Then further, the ACI code has further classified the loads into service and live loads. Service loads are those loads which will be used in the service life of the structure. Okay, that's why they are called as service loads. Okay, and factor loads are those loads which, when service loads are amplified for the purpose of design. For example, actually a load is 50 pounds per square foot, and you say that, okay, I will 20% increase this load or 30% increase this load in order to provide some safety in my design. So these loads, when they are factored, are called as factor loads. So service load, when service loads are multiplied by certain factors, or they are increased by certain percentage, they will be called as factor loads. Okay, and the loads are factored in designs. This is common practice that the loads are increased a little bit by factors recommended by the ACI code in order to ensure safety in our designs. Design procedures. Although we will study these procedures in detail in the next lecture, but just to give you a glimpse of these two approaches, there are two approaches of design. One is called as working stress design approach, and the other is called as strength design approach. I will try to explain these two approaches with an example very quickly. And that example is the example of a weightlifter. Let's say you are a weightlifter, okay? Imagine that you are a weightlifter and you want to take part in a competition of weightlifting, and the weight that to be lifted on a particular day of weightlifting is 100 kg, okay? So the demand is 100 kg. You have to lift 100 kg weight. So we will consider this a demand. Okay, now you exactly know what is the magnitude of the weight, or what is the magnitude of the demand. Now you will look at yourself, your structure, your body structure, whether your body structure can lift this weight or not. You will test yourself. If you are not unable, what you will do? You will start preparing yourself. You will start preparing your body structure so that you can lift the weight. So what will you do? You will start exercising and taking good food. And slowly and gradually, when you practice smaller loads, you can reach to lifting 100 kg weight or even more than that. But in this process of your preparation or training, two things will be achieved in your body structure. One, the area of your muscle will increase. Which is the size that I was telling you in the beginning, that the size must be selected. So this is the size of your body structure, your muscles. And the other is the strength of your muscles will also need to be increased. So in every design problem, you should remember this, and you should write down this in your notes, that in every design problem, be it a civil engineering design, a mechanical engineering design, an area engineering design problem, there are two things using which you can increase the capacity. One is the geometry of that structure, and the other is the strength of the structure. Geometry of the structure means increasing the size. So playing with the size of the structure, you can increase the capacity of the structure. And the other strength of the structure means you should play with the material. If one material is not enough, you should use two material or the combination of two material. And that is what we exactly do in the design of reinforced concrete structures. Concrete is good in compression, so we don't use steel on the in the location where concrete is subjected only to compression, because it is not built over there. We only provide reinforcement, steel reinforcement, in the locations where there are tensile stresses. Our tensile stresses are expected to be produced. So in your preparation, you will start building your muscles. You will also try to increase the strength of your muscle, and by doing both of them, you can achieve the capacity which will enable you to lift the weight. Now, let's say you are able to lift the weight of 100 kg. Your capacity is exactly 100 kg, and demand is also 100 kg. So you have a element of risk in your mind that there is something on the day of competition that you are unable to lift the weight. If your capacity is exactly equal to demand, there will be an element of risk, and always you will think that probably I may not be able to lift the weight on the day of competition. So what you will need? You will need an extra effort to lift a weight of, let's say, 110 kg or 120 kg. Then you will be satisfied and confident that on the day of weightlifting competition, if I can lift 120 kg, so it will be very easy for me to lift a weight of 120 kg, 100 kg. So why are you doing this? You are doing this to have factor of safety in your designs. Factor of safety in so this margin or factor of safety we always like in our daily routine problems. This is also a problem that you want to lift a weight. So if you want to lift a weight, you would like to have margin of safety, and that margin of safety will depend. If you fix your target of 150 kg, then you will have to work a lot, several days, and it may waste a lot of your resources and time. If you make this target as 102 kg instead of 100 kg, so there is only a margin of 2 kg, and 2 kg margin is, I think, very, very small. So this will be fixed, and this will depend from situation to situation. But the bottom line is that there is always a margin of safety that we would like to have in our daily routine problems. And the same thing is true for the design. In designs also, we would like to have margin of safety, and this margin of safety can be introduced in several manners. In a working stress method, this is done like this. The same example. You exactly know that the weight that I have to lift is 100 kg, but you say that no, okay, no, we don't do anything with the weight. We don't do anything with the weight in working stress approach. We say that the weight is 100 kg, it is there, but if my capacity is 100 kg, I will divide this capacity by 2, and I will say that no, my capacity is 50 kg. So once your capacity is 200 kg, then 200 divided by 2 in calculations. For example, if you have a trainer, and the trainer wants to prepare you for the weightlifting competition, so and he wants to calculate your capacity, so he will do like this on a working stress approach. That he will say that, okay, if your capacity is 200 kg, 200 divided by 200 kg. So you should build yourself. You should build your capacity equal to 200 kg, and only then, according to your trainer, you will be able to lift 100 kg. So there is a margin of 2 in this working stress approach. Okay, but demand is kept the same. In a strength design approach, what is done is, in a strength design approach, with the same example, the 100 kg weight that you have to lift on a particular day of competition will be slightly jacked up. You will say to yourself, or your trainer will tell you that you are not going to take part in competition of 100 kg, but 120 kg. So your target will be fixed at 120 kg. The demand is little bit increased, and your capacity will be slightly reduced. That you exactly know that my capacity is, let's say, X, but this X will be multiplied by, let's say, 0.9, and 0.9 times X equal to 120, and x is equal to 120 divided by 0.9, you should prepare for 130 kg. So 130 kg instead of 100 kg, 30 kg is a margin of safety, which is called as factor of safety. So in this way, we will introduce margin of safety in our designs. Okay, this is in the strength design approach. In the strength design approach, it is done like this. As I said earlier, I will now demonstrate this through a slide like this. Let's say your trainer tells you, again in the weightlifting competition, not the actual design. Your trainer tells you that I will multiply 100 kg, which is demand, which we can also write in terms of D. So this gamma is a factor greater than 1. And your capacity in terms of, let's say, C is your capacity that your trainer want to build. Multiply by a factor phi, which is less than 1. So let's say this factor is 0.9. 0.9 times C equal to, let's say this gamma is 1.2. 1.2 times 100. So your C capacity should be equal to 1.2 times 100 divided by 0.9 equal to how much? One 333 kg. What does it mean? It means that you should prepare yourself for 133 kg. In other words, only and only when your capacity is 133 kg, you should go to the competition with a factor of safety of 33 kg. In terms of ratio, this capacity will be equal to 1.2 divided by 0.9. Because if this is demand, D, so in terms of ratio, it will be like this. I hope you can understand this because it's very straightforward. That for 100 kg weightlifting, you should prepare yourself such that your capacity becomes equal to 133 kg and you have a 33 kg margin of safety. Okay, in terms of ratio, it will be like this: phi into C is equal to gamma into D. Okay. Then C divided by D will be equal to gamma divided by phi. And gamma, if it is gamma, let's say it is this, so this will be 1.3. So your factor of safety, capacity divided by D is 1.33. Your factor of safety is 1.33 in this case. We always would like to have factor of safety in our designs, okay? Give me just a 5-minute break because I'm receiving a call, so then we will resume. Okay, the last part of our today's lecture is on the mechanics of reinforced concrete. You know that there are two types of mechanics, qualitative and quantitative. In qualitative mechanics, we deal with the nature of effect of load like stresses. We calculate the stresses. In quantitative mechanics, deal the formulation obtained using the established laws, for instance, equilibrium. We will be discussing this in detail in our next lectures. The mechanics of reinforced concrete will be discussed in every lecture while we discuss the particular design. For example, if we start designing for axial load, we'll be studying the mechanics of reinforced concrete against axial loads, similarly flexure and shear. So the formulation of design equations for axial, flexure, shear, and torsion stress is based on the mechanics of reinforced concrete will be taught in these respective topics. The mechanics of reinforced concrete for flexure will be discussed in detail in the next week lecture. This is the end of this lecture. If you have any question, please don't hesitate in asking questions. I'm here to answer your questions. This is your first course in reinforced concrete design. There may be many questions arising in your minds. You are free to ask questions related to the course. Okay, and you can also send your questions in text. Okay, if you want to ask questions, please ask questions. Okay, during my lecture, if at any time you feel that you want to ask questions and something is not clear to you, you can stop me straight away. Just tell me your name and ask your questions. Okay, don't wait till the end of the lecture. Anytime you can stop me and ask your questions. Okay, similarly, if you don't want to ask questions verbally, then you can also write in the text and you will try to answer your questions. Okay, and then if you want to ask questions in the next lecture, it is also good that you go through this lecture and come up with questions before we start our new lecture. So this will be our strategy, that in every new lecture, we will try to answer your questions in the previous lecture, and then we will begin our new lecture. Anyway, if you have any question in today's lecture, I will just summarize what we have done today, and then you can ask questions. In Urdu, I will now summarize the things. शुरू में आज अगर आपने तवज्जो की हो तो शुरू में हम ये कह रहे थे कि ये कोर्स है रिइंफोर्स्ड कंक्रीट डिज़ाइन का, और चूंकि नाम इसका रिइंफोर्स्ड कंक्रीट डिज़ाइन है तो मतलब इसका ये है कि कंक्रीट का कोर्स है और उसमें हम डिज़ाइन करेंगे। तो क्या डिज़ाइन करेंगे? हम स्ट्रक्चर्स, फ्रेम स्ट्रक्चर्स के जो मुख्तलिफ मेंबर्स हैं, बीम्स, कॉलम्स, स्लैब्स वगैरह, ये डिज़ाइन करना सीखेंगे। क्योंकि ये एक बिगिनर लेवल कोर्स है, शुरू का कोर्स है, तो इसमें आप तो सब चीज़ें तो आप पढ़ नहीं सकते। तो इसमें हम आहिस्ता आहिस्ता एक बीम के डिज़ाइन से शुरू करेंगे। बीम को पहले फ्लेक्चर के लिए डिज़ाइन करेंगे, फिर शेयर के लिए डिज़ाइन करेंगे। आप लोगों ने अपने मुख्तलिफ कोर्सेज़ में शेयर फोर्स डायग्राम, बेंडिंग डायग्राम भी ड्रा किए होंगे, और कई दफ़ा विद इन दी बीम डेप्थ फ्लेक्चर स्ट्रेसेस भी आपने मालूम की होंगी। जिस तरह फ्लेक्चर स्ट्रेस फार्मूला M/I है वगैरह वगैरह आपने किया होगा। वो तमाम चीज़ें हम इस कोर्स में अप्लाई करेंगे। हम ये करेंगे कि बीम है जो कि किसी स्ट्रक्चर का हिस्सा है, तो उस बीम के ऊपर कुछ लोड है, उस लोड ने बीम में क्या बेंडिंग मोमेंट पैदा कर दिया, क्या स्ट्रेसेस पैदा कर दिए, किस पार्ट में कितना स्ट्रेस है, वो हम मालूम करेंगे। उसके बाद हम उस जगह पर जहाँ रिक्वायर्ड हो स्टील बार्स प्लेस करेंगे। मैंने आपको शुरू में कह दिया कि डिज़ाइन का मतलब ये है कि आप जो भी चीज़ डिज़ाइन करें उसकी एक ज्योमेट्री फिक्स कर दें, सेलेक्ट कर दें, यानी साइज़ उसका। ज्योमेट्री का मतलब साइज़ है, उसकी विड्थ और डेप्थ, और उसकी जो मटेरियल है, या एक मटेरियल इस्तेमाल करें, या अगर एक मटेरियल काफ़ी नहीं तो दो मटेरियल का कम्बिनेशन इस्तेमाल करें। तो रिइंफोर्स्ड कंक्रीट में हम दो मटेरियल का कम्बिनेशन इस्तेमाल करेंगे। कंक्रीट कंप्रेशन वाली जगहों पर इस्तेमाल करेंगे और स्टील टेंशन वाली जगहों पर हम इस्तेमाल करेंगे। आल्दो के स्टील कंप्रेशन में भी बहुत अच्छा है, लेकिन चूंकि स्टील एक्सपेंसिव है तो हम स्टील को उस जगहों पर आमतौर पर इस्तेमाल नहीं करेंगे जहाँ पर प्योर कंप्रेशन हो। फिर मैंने आपको ये भी कहा कि मेरा अपना जो फील्ड है डिज़ाइनिंग का, हम काफ़ी डिज़ाइनिंग के काम करते हैं और हज़ारों प्रोजेक्ट्स भी हो डन। اس میں تقریباً اب 100 سے زیادہ ہم ہائی رائز بلڈنگس جو کہ زیادہ تر پشاور میں آپ دیکھیں تو ہائی رائز بلڈنگس ہم نے ڈیزائن کی ہیں. اس میں یہ بورڈ بازار میں اس وقت ایک بہت بڑا پروجیکٹ ہے سیف مال کے نام سے. اٹس اے ہیوج پروجیکٹ. اس طرح حیات آباد میں نارتھ ویسٹ ہاسپٹل جو ابھی جس کا نیا اسٹرکچر ہے, اس کی اسٹرکچرل میٹنگ ہم نے کی. لائف کیئر ہاسپٹل وی ہیو ڈیزائن اینڈ سو مینی ادر پروجیکٹس ان اینڈ اراؤنڈ دا سٹی وی ہیو ڈیزائن ہائی رائز بلڈنگ. ہائی رائز بلڈنگ میں ہم نے کافی کام کیا ہے, برجز میں بھی کیا ہے. تو اس لیے اگر آپ کوئی پریکٹیکل اسٹرکچر دیکھنا چاہتے ہیں کہ کیسے بنتا ہے تو یہ آپ کے لیے ایک اچھا موقع ہے. سیف مال ابھی بالکل انیشیل سٹیج میں ہے. ڈائمنڈ مال کا تو جو ادھر ابدرا کے پاس ہے اس کے 4-5 فلور اب روڈ سے نظر آتے ہیں, آپ دیکھ سکتے ہیں جا کر کسی بھی وقت. تو یہ پھر ہم نے یہ بتایا کہ ہم جو یہ ہمارا کورس ہے اس میں بیسیکلی 3 چیزیں ضروری ہیں. ایک پراپرٹیز آف کنکریٹ اینڈ اسٹیل ہے, دوسری کورس کے متعلق ہے, اور تیسری میکینکس ہے. تو کنکریٹ کے متعلق میں نے آپ کو بتا دیا کہ کنکریٹ کا اگر آپ کمپریشن اسٹرینتھ معلوم کرنا چاہیں, آپ کسی فیلڈ پر کام کر رہے ہوں تو آپ اس کا سلنڈر بھر کے ادھر ٹیسٹ کر دیں. 3 ڈیز 7 ڈیز کا آپ نے کیے ہوں گے. اور اسٹرینتھ جو ہے انڈیکیٹر ہے کنکریٹ کی کوالٹی کا. اسٹرینتھ جتنی اچھی ہوگی کنکریٹ کی کوالٹی اتنی اچھی آپ کے پاس آئے گی. عام طور پہ 3-4 ہزار 5 ہزار ہم پشاور میں عرصے دراز سے استعمال کرتے ہیں, لیکن اب ہم 6 ہزار 8 ہزار کی SI بھی مختلف قسم کے ایڈمکسچر سے استعمال کرتے ہیں. اگر آپ کو ہائی اسٹرینتھ کنکریٹ بنانا ہے تو آپ ایڈمکسچرس کے بغیر نہیں بنا سکتے. اس میں سپر پلاسٹیسائزر ہے, سلیکا فیوم ہے, وغیرہ وغیرہ آپ استعمال کر کے اس کو اچیو کر سکتے ہیں. اچھا, اس کے بعد ہم نے یہ کہا کہ اسٹیل کی پراپرٹیز گریڈ 40-60 اسٹیل پاکستان میں استعمال ہو رہے ہیں. اس میں بتایا کہ ASTM A615 ایک اسٹینڈرڈ ہے, اس میں پراپرٹیز کی لسٹ دی ہوئی ہے. اگر آپ کو کوئی بتا دے کہ یہ اسٹیل ہے تو آپ کو کیسے پتہ چلے گا کہ یہ اسٹیل میں اپنے اسٹرکچر میں استعمال کر سکتا ہوں یا نہیں. تو آپ اسٹرکچر میں اسٹیل اس وقت استعمال کر سکتے ہیں جب یہ ASTM A615 کو سیٹسفائی کرتا ہو یا ASTM A706 کو سیٹسفائی. اگر ان دونوں کو سیٹسفائی نہیں کر سکتا ہو تو آپ اسٹیل بار چاہے کتنا بھی اچھا ہو آپ استعمال نہیں کر سکتے, کیونکہ ACI کوڈ کی بنیادی ریکوائرمنٹ ہے کہ آپ جو بھی اسٹیل استعمال کریں وہ یا ASTM A615 ہو یا ASTM A706 ہو. اگر ان دونوں میں نہ ہو تو آپ وہ اسٹیل اپنے ڈیزائن میں استعمال نہیں کر سکتے. پھر میں نے یہ بھی بتایا کہ گریڈ 40 کا اسٹیل ہوتا ہے, 60 کا اسٹیل ہوتا ہے, وہ اس کو یو اسٹرینتھ ہے. ٹھیک ہے. اس کے بعد ہم نے میکینکس پہ بات کی, بار ڈیزگنیشن پہ بات کی, اینڈ سو آن. تو یہ تو خلاصہ تھا آج کے لیکچر کا جو میں نے اردو میں چاہا آپ سے ڈسکس کروں. کچھ اسٹوڈنٹس نے ریکویسٹ کی تھی کہ آخر میں اردو میں آپ سمرائز کریں, میں نے کر دیا. اب اگر آپ کو کوئی کوشچن ہو تو یو فیل فری ٹو آسک کوشچن پلیز.
سر میرا نام محمد علی رضا ہے. سر میرا کوشچن یہ ہے کہ فاؤنڈیشن کے اندر تو سر ہمارے پاس ٹوٹلی کمپریشن ہوتی ہے, تو سر پھر ہم وہاں مطلب یہ کیوں یوز کرتے ہیں ریبارز یا رینفورسمنٹ؟
فاؤنڈیشن کو اگر آپ امیجن کریں نا تو جہاں پر بیم کالم کو پش کرتا ہے, آپ اس طرح کریں کہ ایک ربر کا, اگر آپ کے پاس کوئی ربر ہو یا اس قسم کا فلیکسیبل مٹیریل ہو, آپ اس کو درمیان میں پش کریں اور پھر امیجن کریں کہ اس کے ساتھ کیا ہوتا ہے. تو یہ سائڈوں سے اڑ جاتا ہے. آپ نے دیکھا ہے, آپ امیجن کر سکتے ہیں. اگر آپ کسی ربر پیڈ کو یا کوئی فوم آپ لے لیں اور اس کو پریس کریں ان دا سینٹر تو اٹ ول بی پشڈ اپ فرام دا ایجز. ایسے ہے کہ نہیں؟ اٹ ول بی لفٹڈ اپ فرام دا ایجز. یہ ایجز اس کے اوپر اڑ جائیں گے. Can you imagine this?
یس سر.
تو جب یہ اوپر اٹھتے ہیں تو یہ ایز اے کینٹیلیور بیم کی طرح, جس طرح کہ نیچے سے آپ کی کینٹیلیور بیم اوپر پش کرتے ہیں نا, تو نیچے سائڈ پہ ٹینسائل اسٹریس اس میں پیدا ہو جاتے ہیں, اوپر کمپریشن. تو نیچے ہم اس میں جال لگاتے ہیں اسٹیل کا انفورسمنٹ کرتے ہیں. آپ اس قسم کے اینیمیشن یا ایکسپیریمنٹس خود بھی کر سکتے ہیں, کیونکہ ڈیزائن جو ہے یہ بہت کامن سینس مانگتا ہے کہ اس میں آپ کو جب پتا ہو کہ ٹینسائل اسٹریس کس سائڈ پہ پیدا ہوتا ہے پھر میگنیچیوڈ معلوم کرنا تو نیکسٹ اسٹیپ ہے. تو دیکھیں آپ نے جس طرح کوشچن کیا کہ آپ کا خیال تھا کہ کنکریٹ کا پیڈ جو ہے یہ پیور کمپریشن میں ہے, لیکن میں نے بتا دیا کہ جہاں پر کالم اس کو نیچے پش کرے گا تو پھر زمین اس کو اوپر پش کرے گی. اب یہ سائڈ سے تو فری ہے تو یہ اوپر اٹھ جائے گا, جب اوپر بینڈ ہوگا تو نیچے ٹینسائل اسٹریس آ جائیں گے. ٹھیک ہے, اس طرح آپ امیجن کریں. آپ
یس سر, تھینک یو.
اینی ادر کوشچن؟ آپ کوشچنس کریں اس میں, کیونکہ آپ کا انیشیل لیول کا کورس ہے. تو اف یو ہیو اینی کوشچن, کوئی بھی کوشچن آپ کے ذہن میں آئے تو آپ بالکل کوشچن کریں. ٹھیک ہے.
ایکسکیوز می سر.
جی پلیز.
سر ہم نے اسٹیل مینوفیکچرنگ کے 2 اسٹینڈرڈس پڑھے, ایک 615 اور ایک 706. تو ان دونوں سے جو اسٹیل مینوفیکچر ہوتا ہے کیا یونٹ ویٹ دونوں کا سیم ہوتا ہے؟
یونٹ ویٹ میں اور ماڈولس پلاسٹسٹی وغیرہ میں اتنا فرق نہیں ہوتا، ان کی باقی پراپرٹیز ڈکٹیلٹی میں. ASTM A615 جو ہے جس طرح میں نے کہا کہ کاربن سٹیل ہے، اور اس کی جو اسٹرینتھ آتی ہے کاربن کی ایڈیشن سے ہمیں ملتی ہے نا. اور ASTM A706 سے یہ صرف ایڈیشن آف کاربن سے نہیں ہوتی، بلکہ اس میں اور بھی چیزیں ڈال کر اس کو تھوڑا ڈکٹائل بھی بناتے ہیں اور اس کی ویلڈیبلٹی کو امپروو کرتے ہیں. ٹھیک ہے، جبکہ ASTM A615 کی اتنی اچھی ویلڈنگ نہیں ہوتی، اس کی ویلڈیبلٹی ASTM A706 کے بارے میں ذرا ویک ہے. اور ASTM A706 رسٹنگ کو ریزسٹنس بھی بہت زیادہ ریزسٹ کرتا ہے، جبکہ ASTM A765 اتنا ریزسٹ نہیں کرتا. لیکن پھر کاسٹ ASTM A615 کی افورڈیبل ہے اور ASTM A706 ذرا مہنگا ہے، تو اسپیشل پروجیکٹس میں ہم اس کو استعمال کرتے ہیں. آپ ذرا اس کی مزید ڈیٹیل دیکھنا چاہیں تو آپ کو نیٹ پہ کافی ساری چیز اس کے بارے میں مزید بھی مل جائیں گی.
سر پھر جب اپنی کیلکولیشنس میں یوز کریں گے تو پھر 490 پاؤنڈس پر کیوبک فیٹ ہی یوز کریں گے یونٹ ویٹ؟
بالکل ہاں، 490 استعمال کریں گے، یونٹ ویٹ میں فرق نہیں پڑتا.
ٹھیک ہے سر، تھینک یو.
Any other question? Questions کریں آپ.
سر ایکسکیوز می سر.
پلیز.
سر میرا نام جنید علی ہے. سر ہم کنکریٹنگ، سر لیٹ سے ہم ایک برج کی کنکریٹنگ کر رہے ہیں نا، اور وہ برج بہت بڑا برج تھا اور کنکریٹنگ پوری کر لی. بعد میں لیب میں ہم نے کنکریٹ کو ٹیسٹ کیا اور پتہ چلا کہ اس کی کمپریسو اسٹرینتھ یہ فیل ہو گیا ہے. تو سر ہم اب اس برج کو وہ ڈسمینٹل کریں گے کہ کیا کریں گے سر؟ اب جو کنکریٹ کا جو ہم نے سائڈ پہ پور کر دیے سر.
اچھا، آپ کا سوال تو میں صحیح نہیں سن سکا، لیکن جتنا میں سن سکا میرے خیال میں یہ تھا کہ آپ برج کی بات کر رہے ہیں. برج
سر کوئی بھی اسٹرکچر ہو، سلیب ہو، کوئی بھی بلڈنگ ہو، ہم نے کنکریٹنگ کر لی سر.
اوکے ٹھیک ہے. اچھا، میں نے آپ کو اپنے لیکچر میں کہہ دیا کہ کنکریٹ کی جو کوالٹی ہے اس کو ہم کنکریٹ کی کمپریسو اسٹرینتھ سے ٹیسٹ کرتے ہیں. اگر آپ کسی سائٹ پہ سائٹ انجینئر کے طور پہ کام کر رہے ہیں، یا پروجیکٹ مینیجر ہیں، یا پروجیکٹ ڈائریکٹر ہیں، یا ریزیڈنٹ انجینئر ہیں، تو آپ کی ایک رسپانسبلٹی یہ ہوگی کہ کنکریٹ کی کوالٹی کو چیک کریں. اور کنکریٹ کی کوالٹی کو آپ اس طرح چیک کریں گے کہ جو ڈیزائنر نے ڈرائنگ آپ کے پاس بھیجی ہوگی اس نے اس میں لکھا ہوگا کہ یہ اسٹرکچر میں نے ڈیزائن کیا ہے، لیکن اس پہ کنکریٹ کی اسٹرینتھ 3000 PSI، 4000، 5000 یہ اتنی نہیں، کالم میں اتنی، بیم میں، سلیب میں اتنی ہونی چاہیے. آپ کی ڈیوٹی یہ ہوگی کہ جب کنکریٹ کی پورنگ ہو تو آپ اس میں سے سیمپل لے کر، اس کا اپنا طریقہ ہے، وہ بھی ACI میں مینشنڈ ہے کہ کتنے سیمپل آپ لیں گے اور اسٹرینتھ ٹیسٹ کس کو کہتے ہیں وغیرہ وغیرہ، وہ ساری لمبی چوڑی چیزیں ہیں. لیکن آپ ادھر سے سلنڈر لے کے ادھر ٹیسٹ کریں گے. اب اگر یہ اسٹرینتھ ٹیسٹ آپ کا فیل ہو گیا، فیل ہونے کا مطلب یہ ہے کہ جو اگر لیٹ سے 5000 PSI اسپیسیفکیشن میں لکھا ہوا تھا لیکن آپ نے ٹیسٹ کیا اور 5000 PSI نہیں آیا، تو اب آپ کیا کریں گے؟ تو ACI نے اس چیزوں کو ڈسکس کیا ہوا ہے. کوالٹی کنٹرول کا ACI کا جو چیپٹر ہے اس میں انہوں نے لکھا ہوا ہے کہ کتنا کم آ جائے تو ایکسیپٹیبل ہے، اگر اس سے بھی کم آ جائے تو دین اس کے بعد بھی ڈیمالش نہیں کرنا ہے، بلکہ اس کے بعد کیا کرنا ہے؟ اس کے بعد یہ کرنا ہے کہ اس ریڈیوس پراپرٹیز کے ساتھ آپ دوبارہ اپنے اسٹرکچر کو چیک کریں. ڈیزائنر کو کہہ دیں گے کہ یہ مسئلہ ہو گیا ہے، کنکریٹ کی اسٹرینتھ تو کم آ گئی، تو اب آپ دوبارہ ذرا اسٹرکچر کو چیک کریں کہ اس کم اسٹرینتھ کے ساتھ کیا ہو رہا ہے. اچھا، اگر وہ کہتا ہے کہ کم اسٹرینتھ کے ساتھ تو ٹھیک ہے، بس آپ چلائیں اس کو، تو اب آپ اوکے کر دیں گے. لیکن کنٹریکٹر کو آپ پیسے نہیں دیں گے. کنٹریکٹر کو پھر آپ پیمنٹ جو کریں گے وہ آپ ریڈیوس اسٹرینتھ کے حساب سے کریں گے، کیونکہ ہر اسٹرینتھ کی الگ الگ پیمنٹ ہوتی ہے. لیکن اسٹرکچر آپ ڈیمالش نہیں کریں گے. ون سیکنڈ تھنگ یہ ہے کہ ہو سکتا ہے کہ ڈیزائنر آپ کو یہ کہہ دے کہ آپ جو اسٹرکچر آپ نے جس ویٹ کے لیے بنایا تھا وہ ویٹ آپ ذرا کم کرے تو پھر یہ کام کرے گا، تو اس کو کہتے ہیں ویٹ ریڈکشن، پھر ہم وزن کم کریں گے. تھرڈ یہ ہو سکتا ہے کہ آپ کو ڈیزائنر کہہ دے کہ اس میں ہر جگہ پر تو مسئلہ نہیں ہے لیکن فلانی جگہ پر مسئلہ ہے، باقی ٹھیک ہے. تو اس جگہ کا جو مسئلہ ہے اس کو پھر آپ کریکٹ کر لیں، ٹھیک کر لیں. تو یہ مختلف سٹیجز ہے. بالکل آخر میں جا کر جب یہ کچھ بھی نہیں ہوتا تو پھر ہم ایک لوڈ ٹیسٹ کرتے ہیں، وہ بھی ACI کوڈ طریقہ اس کو بتا ہے کہ آپ ایکچولی اس پہ بوریا رکھیں گے، سینڈ بیگ یا کچھ ٹیسٹ کریں گے. اس ٹیسٹ سے پھر آپ دیکھیں گے کہ اس میں کتنی ڈیفارمیشن وغیرہ آئی ہیں. اگر وہ پاس کر دے تو آپ الاؤ کریں گے، نہیں تو پھر اس کے بعد آپ ڈیمالش کریں گے. تو یہ کافی ساری اس میں چیزیں، ایک سٹیپ نہیں ہے کہ فوراً آپ ڈیمالش کر دیں.
اوکے سر.
سر میرا نام وسام ہے. میرا کوشچن یہ ہے کہ اکثر ہم دیکھتے ہیں جو لوکل پروجیکٹس پہ اکثر لوگ جو ہے درمیان میں بیم کے درمیان پہ بھی اسٹیل بارز لگاتے ہیں، تو بیم کے درمیان میں تو ٹینشن نہیں ہوتی، تو اس کو لگانے کی کیا وجہ ہے, کیا ہے صحیح ہے؟
یعنی along the depth آپ کہتے ہیں کہ درمیان میں جہاں پر نیوٹرل ایکسس ہوتا ہے, یہاں پر سینٹرائڈل ایکسس, یہی ہے نا, یہی آپ کہہ رہے ہیں نا؟
یس سر, یہی کہ
اچھا ہاں, تو اس کی ضرورت ہے. ایک تو جب بیم کی ڈیپتھ بہت زیادہ ہو جائے تو آپ اس کو میرے خیال میں کورس میں تو نہیں, لیکن نیکسٹ کورس میں آپ پڑھ لیں گے. جب بیم کی ڈیپتھ بہت زیادہ ہو جائے تو اصل میں یہ جو سینٹرائڈل ایکسس, جس کو ہم اس کورس میں نیوٹرل ایکسس بھی کہیں گے, اور ہو سکتا ہے کہ آپ لوگوں نے بھی کسی کورس میں نیوٹرل ایکسس پڑھا ہو. نیوٹرل ایکسس بیم میں وہ ایکسس ہوتا ہے کہ جہاں پر کسی قسم کا اسٹریس نہیں ہوتا. یہ بات تو آپ جانتے ہیں. جب کنکریٹ کو ہم لوڈ کرتے ہیں نا تو یہ نیوٹرل ایکسس اپنی جگہ پر درمیان میں نہیں رہتا, بلکہ اوپر شفٹ ہوتا رہتا ہے, کیونکہ کنکریٹ نیچے سے کریک ہوتا جاتا ہے. میں آپ کو نیکسٹ لیکچر میں ایک ویڈیو دکھاؤں گا کہ کنکریٹ کا بیم کیسے فیل ہوتا ہے. تو جیسے جیسے اس میں کریکس کنکریٹ میں آتے جاتے ہیں, جو نیچے کریکٹ ایریا کنکریٹ کا ہوتا ہے اس کو ہم کہتے ہیں کہ بس یہ ختم ہو گیا. تو اس وجہ سے کنکریٹ کی ڈیپتھ جو ہے ایسا ایسا کم ہونا, کنکریٹ بیم کی ڈیپتھ کم ہونا شروع ہو جاتا ہے, جس کی وجہ سے نیوٹرل ایکسس بھی اوپر شفٹ ہوتا جاتا ہے. تو نیوٹرل ایکسس آخر میں بالکل اوپر کنکریٹ کے بالکل ٹاپ پورشن میں ہوتا ہے, اور باقی نیچے ٹینشن ہوتا ہے. تو وہ جو نیچے سٹیل بار پڑے تھے, اگر بیم کی ڈیپتھ بہت زیادہ ہو تو وہ بالکل شروع میں اس میں کریک آ جاتے ہیں. اس لیے درمیان میں کچھ سٹیل بار بھی ہم کو لگانے پڑتے ہیں, کیونکہ یہ نیوٹرل ایکسس پر نہیں رہتا بلکہ وہ ٹینشن زون بن جاتا ہے. لیکن یہ بیم کے ڈیپتھ پہ ڈیپینڈ کرتا ہے. اگر بیم کی ڈیپتھ 3 فٹ سے زیادہ ہو یا 3 فٹ ہو تو اس میں یہ صورتحال ہوتی ہے. دوسری ایک صورتحال یہ ہو سکتی ہے کہ بیم کی ڈیپتھ تو زیادہ نہ ہو, لیکن پھر بھی اس کے سینٹر میں 2 بارز آپ دیکھیں, یعنی along the depth میں سینٹر کہہ رہا ہوں, along the depth of the beam. وہ اس لیے ہوتا ہے کہ جب بیم میں ٹارجن اسٹریسز ایکسپیکٹڈ ہونا, اور تو اس میں پھر ٹارجن کے لیے یہ درمیان میں سریے لگاتے ہیں. اگر ٹارجن نہ ہو اور بیم کی ڈیپتھ بھی زیادہ نہ ہو تو پھر درمیان میں 2 بار لگانے کی کوئی ضرورت نہیں.
اوکے, تھینک یو سر.
Any other question? Good questions are coming. If you have any question, please ask your questions. Okay, if there are no further questions, then it is the end of today's lecture. Thank you very much for listening. And if you have questions, you can come up with your questions next time. Okay. Allah Hafiz. Assalamu alaikum.
Thank you, sir. Assalamu alaikum.